If you're getting me, please type something. All right, guys, I think I'm going to start. I'm going to start by introducing myself. I'm by names Chanwa Tilari, a student of Makerere University, pursuing a bachelor's degree in education, science, physical, that's physics and math. Now, the reason as to why I organize this discussion is because most people, most of the people who are doing edu, at some point you're going to need to typeset your document, most especially the science students. So you have to say maybe type notes or question papers and stuff like that. And so you need a program that will help you to one, easily type those equations and expressions, and two, to also organize your documents. Say maybe you want your document to be in form of a PDF. So that's why we need this program. So the first thing that we shall look at is the pronunciation. So okay, so it's not pronounced latex the way some of you do. It's pronounced latex because it's Greek, it's not English. So most people call it latex. It's just a make do, because writing it latex is kind of hard. If you are to write it in Greek, it's written as T epsilon, then this X. So most of the programs we use do not support writing this. That's why most people now call it latex, but it's called latex. Now to continue, just a disclaimer is, one, I'm not an expert yet. I'm also just learning like you people. And then two, this is a discussion, so we're expected to share any knowledge that you have that I may not have, you are supposed to share. And then in case I make a mistake, please feel free to correct me. So let's start. The big question is, what is LaTeX, right? So it's a math typesetting program, which is primarily used by mathematical students and other academia to help us typeset mathematical notations and is easily and legibly. So that's basically what LaTeX is. So now, to run LaTeX on your PC, you need to install Mixtec and then text maker. Now, Mixtec is like a compiler, or it's that part of that software when you install in your PC that will understand the codes that you've written in LaTeX. And then text maker is just a text editor. You can use another text editor like You can use any other text editor like say Notepad, which is usually on all PCs and others. So now LaTeX output in three different forms: the device independent file format, and the PostScript file format, and then the portable document format, which you are all familiar with. It's called PDF, and it's the one we're going to be looking at because it's most common now. So if you look at the structure of a LaTeX document, right? So this one here you're saying is from this is an extract from TextMaker, right? Now, a LaTeX document, the codes, there are two parts. There's the preamble. Yes.
You can zoom your screen. It's somehow small.
Okay, let me zoom it. Here, if you look at it, this one, I got it from excuse me, from TextMaker, which is a text editor, as I told you before. Now, so the LaTeX document has two parts: the preamble, which is the first part here, the upper part here. You see this part. This part here is the preamble, the one which is lined in red, which has a red outline. Now, and then we have the document environment. Now, the document environment, this is where you put your codes, what you want to be printed in form of PDF. That's why you put your codes. That's our document environment. Of course, we shall dive into them one by one and see what they do and their importance. Now, let's start with preamble. Now, so the preamble has different parts, right? The first part we are looking at is the document class, this one. So the document class tells LaTeX what kind of document you're using, which then tells it to load certain features that are required for that type of document. Now, it's always written as, so it's always written as this, as what you're saying here. So / document class, then the type. Now, there are different types. There are different types. Well, we have the document class article, and then we have the document class examination. But in this example, in this discussion, we shall be looking at article and example. There are very many others. There are many others that we shall look at. Okay, there are very many other document class types that exist, but for our case, we shall only be looking at the article and the exam. Then maybe if someone wants to have a presentation format, then you can use the Beamer, the Beamer document type. Now, so still in the preamble, we shall look at the packages. In our case, this one, these are the packages. Now, packages are files that have extra LaTeX commands that allow you to do even more with LaTeX. There are quite many of these, but for now we shall focus on those, I think, which are fundamental for our discussion. Now, LaTeX has several features, several uses. So the packages, these are just commands that have additional functions that you can use for LaTeX. So the first we shall look at, so first of all, before we even go into the different packages which are available now. So if you want to use a package, right? To use a package, we use the following code. The backslash use package, then this is an optional field. You can leave it out, then the package name. Now, when you're writing the package name, make sure that you spell it correct the way it is, because if you make a mistake in spelling it, then the compiler won't understand. So let's look at the examples that we shall look at. We have the geometry package. Now, this geometry package is not really so fundamental in typing in typesetting math, but now LaTeX by default has a margin set at 1.85 inches, which is a little bit wide, and it can be a little bit frustrating when you're using it. So this package would help us to customize our margin. Now, in this case, we are setting the margin to 1.25 inches, which is a little bit nice to look at. So that's what the package, the geometry package does. Then we shall look at the AMS math and AMS YMB packages. Now, the AMS math package contains a lot of the magic that makes LaTeX a good choice for typesetting math. So remember, as what I said now. So these packages are written by people, right? People just like you, right? Say they're using LaTeX. Guys, just a reminder, this is a recurring Zoom discussion. So after some time, we shall be coming back, like it will log us out, then we shall log in again. So as I was saying, the AMS math package, it contains, say, those expressions that we shall be using for typesetting our math documents, and it's maintained by the American Mathematical Society. Now, then the AMS symbol package. Now, this one contains the different symbols that we use, right? We shall look at that into details just in a few minutes. Then, of course, we have the graphics package. Now, this graphics package helps us to add images to our document. Okay. Now, that is to do with the preamble. Now, let's look at the document environment. Now, the document environment is where the actual content of our document will go. So in this case, we have that. So this is what we type in the document environment. What we type in the document environment, which is here, is what will appear here. Now, what happens in the preamble is these codes in the preamble control what happens to codes in the document environment. So let's dive into the structure of the document environment. So if you want to, if you go back to the previous slide, you realize that our document environment begins with begin document and end document. So now all these backslashes are telling LaTeX that it's trying to communicate to LaTeX what you want to do, because just like this normal language that we speak, there are rules that we follow to speak them, and it's the same thing. Sorry, and it's the same thing. So let's continue. So let's look at the structure of the document environment. Now, so to start the document environment, we begin with we start with begin document and close that by end document. Now, if you don't put these two, then LaTeX won't understand what you're trying to do, what you're trying to put there. Now then, our codes will fall in between those two. So in our example here, you see that this, we shall look at this much later, but this is what this small sample of code will display in our output. So the rest of this discussion is learning to communicate with LaTeX so that it does what we want it to do. Okay. Okay. Let's continue. So let's start looking at the basic text manipulation in LaTeX. So in the next few slides, we'll be talking through the basics of manipulating text in mathematics using LaTeX. Now, so this basic text manipulation basically has to do with things like increasing text font size, text emphasis, say bolding text, underlining text, and that. So the first thing we shall do is we start with text modification in the document class portion, right? Now here, this optional portion that I left out in the beginning, that's what we are talking about. Now, let's look at an example. So in the document class, now by default, LaTeX usually sets the font size to 10 points, right? Now, so just say maybe you want something bigger. So now when you set it here, when you set it here to 10 points, so it is telling LaTeX that all of your documents should have font size 10 point. Here, when you set it to 11, it's telling your document that all of your, it's telling LaTeX that all of your document should be set to 11 point. So when you set it to 12, it is telling LaTeX that the whole of your document should be set to 12. And this is supposed to be here in this square bracket. So there are other ways of impacting font size, right? Other than, sorry. Other than that, so we have changing the text size. So this is what I was meaning now. Yeah, okay. So in the examples we have seen, which we already talked about, the font size was set to 10 point, 11 point, and 12 points. Now, this is how the text would look like if we set them. So to 5 point, that's the size, which is tiny. Then we have the script size, which sets to 7 point. And then we have the footnote size, which sets to 8 points. Then, of course, normal, which is 10, which is the default size for LaTeX. And then we have 12, which is 12 points. That is large. And now, if you notice, the large here, it starts with small l, which sets it to 12 point. Then the large, which sets to 14 point, starts with capital L. Then we have large, which is in all caps, which sets to 17 points. This is what I'm talking about. Then we have that, and then huge, which sets to 20 points. Then there is a huge, which starts with capital H, and it sets to 25 points. So there are two ways of changing text size. Now, the first is to use it as a switch. Now, using it as a switch, this is how we use it as a switch. Now, we have, so when you use it as a switch, you will have switch over to that font size until you switch it back. This can be good if you want, can be good in practice. If say you want to change your font size for say the end of your paragraph. So let's have a look at the example. This is an extract from TextMaker. So these are our codes, right? We have normal size, then we are switching here. So we are switching from the normal font size to large, because this is the normal font size. Then now we are switching, if you notice from here, we have the normal font size, right? Normal size text. Then here, we have switched to large because of this command. Now, this command changes from the normal, which is 10 point, to large, right? And that's why we have this display. Then most of the time, when we are changing the font size, we change for a few words. So in this case, it's recommended we use the curly brackets to limit the scope. Now, a scope is say a lifeline of that code. So what it simply means is, now, what it simply means is, outside of these curly brackets, this text formatting will not be valid, right? So that's what we mean by the scope. So the scope is just a lifeline of that formatting. So this is what I mean now. This large here this is our output, but you see that this text, which is outside of this text, which is outside of this curly bracket, is not formatted. The size remains the same. So that's because this bracket and this have created a scope, the lifeline of that code. And an example is like if you have fish in water. So now these curly brackets in our example signify, say, the size of the lake. Now, then this large here, right, signifies the water in that lake. Then our text large, this one, is like fish in that water. Now, that the fish in that water, which is large, will have the formatting. But if you take it out of this, there will be no formatting. So let me say we are assuming that initially we had two. We had the large and the text. From here, if you look at this, we had the large and the text. They were all, say, there are fish in that water. But in our case here, we have taken the text out of that out of the water using our curly brackets. So to create a scope. So which means this text which is outside of the bracket is not going to be edited. So that's what we mean using the curly bracket. It's almost like switching, but then the thing with it is it has a limitation. So so just in case maybe these font sizes are not enough for you. So this is what I mean. This is an extract. You can see You will zoom it in just a little. Now, here, so here we have the brackets, this kind of brackets that are creating the limits of the scope, which is here. So the curly bracket has created a limited scope. So which means anything outside of this bracket, our example is the text, it won't be, the size won't be changed. So that's why we have this. We have only large, which is being formatted, and then the text is not, which is different from this example, right? Because in this example, we had a switch. So what the switch means is like, so we started with normal font size, then we introduced this code, the large. So we are switching from the normal font size now back. Sorry, we are switching from the normal font size to a larger font size. So that's what that switch means. So that's why you see from here, anything which is to the right of this code, anything which is to the right of this code is going to be formatted. While if you look at this, anything which is outside our bracket is not formatted, but everything that is inside this bracket is going to be formatted. So the font size will change to large. That's what I mean. Now, so just in case you want to use other font sizes, if all these other font sizes we have seen, you feel they are not enough for you, there are packages that can offer you other different font sizes. Just as I said, these are packages are just files that tell LaTeX to do more. So let me say, so these people who wrote these other packages, they felt like these font sizes that are provided by LaTeX were not enough. So they decided to have their own. And I already showed you how to use a package. So you go in the preamble and you use this command, use package. Then you open and close curly brackets. You open and close curly brackets. Then inside your curly bracket is where you will have the name of the package. So let's say you can have ext size. These packages you can read about them at your free time. I'm not going to look at them. So the next text manipulation we shall look at is font style, right? So which is the bold type, the italic, and the underline. So we use this by typing the appropriate commands and the text to be formatted. Now, the appropriate command for bold is this. Let me zoom in. It's // text bold font. This is just bold font, but you don't type bold font, you just type text BF. Then now this one inside is now the text that you want to format to change the size. Yeah. So this is what this would be our output. Then we have italic font style. This is the command. The command is text it. Then inside of it we shall have so inside of it here is where we shall have the text that we want to change the style. So this would be our output. It's freezing. Yeah, this would be our output. And then the next font style we shall look at is underline. With the command So if you want to underline your text, this is the command. You just use backward slash, then underline. Then inside here is where inside here is where the text you want to format or to underline is going to be put. So this would be our output. Then now, if you notice this text styling now, for the previous, when we were changing the font size, we were using a switch statement now, which is different for our case here, because here we have the curly brackets. Now, these curly brackets make this look as functions, not switches. So this will be like functions, not switches. Now, the advantage of a function is you can have nesting. So nesting is like you can have, say, you can have 3 different stylings for the same text. So this is what I mean now. So we apply the font modifier. So we can so like in this example, we have the bold, then italic, then underline. They are all trying to format this text here. They are trying to format this. Now, if with the switch, you cannot have, say, large, then say,
Excuse me.
yes.
Like I'm seeing 3 brackets at the end.
Yes.
Then I'm not seeing the first 3 brackets.
Come again.
I don't know whether it's supposed to be first 3 brackets.
No, it's not.
Like I'm seeing 3 brackets at the end.
And then you're not seeing them at the beginning.
Yes.
Okay, so the reason is now let me use a different color. Okay, the reason is so this bold format here. So okay, this is how I wrote the code. Start with text bold font, right? Now, so what this simply means is the text that we are going to underline and make it in form of italic is supposed to be bold. And that's why you're seeing the green back bracket here and the green bracket here. So which means these other stylings here, they're all falling inside the bold. I hope you're getting me.
Yeah, I'm seeing them now, like 4 text I can see. Then
So
go underline like that.
This which corresponds to that. Then there's this which corresponds to that. Is it okay now? So this,
yeah.
Okay. So this would be our output for that. So the bold which we are seeing is for the whole text, right? So what this means is, 1, we are going to first underline the text, right? Then after underlining our text, we shall make it in italic form. Then after that, we shall make the whole text bold. That's what it means. So so this is what I was talking about. So these are the exact codes from text maker. So okay, now these are the exact things that we've been talking about previously. So we have this for bold, right? And then we have this for italic, then this for underline. So now, and these are their outputs. Still, the bracket, if you see this bracket, then there's this, then there's this. Now, there are 3 opening brackets, so you must close all of them, because if you don't, then you're going to have an error when you're running your code. Yeah, so and these are the different outputs. So if for a normal text will look like this. Then text which of bolden, this is how they will look like, and then that for the rest. So again, we're talking about nesting, right? So what that means is, excuse me, what that means is, now this text 1, we are first going to make the text in italics form because of this command. Then after, we shall make it bold. So that's why we have this output here. The same thing here. We first underline this text. Then after underlining the text, we make it bold. That's why we have this output here. Then for the next one, we shall first underline the text. After underlining, we make it in italics form. The same with the last one, which we already looked at. So the most important thing is, the most important thing in this case are the brackets. So where you're opening your brackets and where you're closing them. So here, this is our opening bracket. Now, the closing bracket of this bracket is this one, because it's the final styling that we're going to have. Then here, this is our opening bracket. Then the closing bracket is this one. The same with this and that. Okay. So the next text manipulation is going to be text emphasis. Now, text emphasis, say if you're using text font styles to emphasize certain text or phrases, you may want to use text emphasis. Now, this tells LaTeX that you want the text emphasized, but it will choose how to do it depending on the surrounding context. So the key thing here is depending on the surrounding context, and we shall look into that into detail. So the syntax or way of writing it is this. So that's how you emphasize your text. Now, what is the text which is going to be here? Is going to be emphasized. Now, so let's look at an example. So we have regular. So this is a regular text, right? Now, then this emphasis is a text that has been emphasized. Then this one is just a normal text. So this is how it would look like, right? So someone may say that this font, this text has been made in italics form. Why won't you use it? Now, remember, we're saying that this text emphasis works based on the surrounding or on the context where what we want to emphasize is. So this is how it would look like in the text editor, which in our case is text maker. Now let's look at another example. Now in this case, right, we have so we have italic, right, and then we are emphasizing. Now the output of this is going to be different from the output of this. Why? Because text emphasis work basing on the context where this text we are trying to emphasize is going to be. Now let's have a look at the output. So this would be the output. Now, you realize that this other text, this text here is not in italic form, but these two here are. Why? Because now the context in which this text we are trying to emphasize is italic. So which means the rest of the text are going to be in italic form. So emphasis, so we're just trying to make it to stand out of the other text. So if it was also italic like the others, then we have not emphasized anything, right? Now, so what this text emphasis does is, instead of making it italics like the rest, or like in this previous example, it's going to make it in form of a normal text. So we are trying to emphasize it out of the other text. So that's what text emphasis does. So this would be the output. This would be the output, right? Let me zoom in just a little bit. Right? So now, so this command makes anything that's inside of this bracket to be in italics form, right? So our output would be in italics form. But then we want to emphasize this text emphasis, right? So that's why we have this command. And that's what would be in our output, right? Because our text, the whole of the text in this, say in this paragraph, was supposed to be in italics form, but we wanted to emphasize this word emphasis. So that's why it is not in italic form, but the rest are. Okay. So that is that. This is another example, right? So this is another example. Now, we have emphasis. So we're trying to emphasize what is in this bracket. Now, after emphasizing what is in that bracket, this command is trying to emphasize emphasis, which is already in this bracket. So we're trying to make it look different from the rest of the text. That's basically what emphasis means. We're trying to make it look different from what the others are. So what it does is, so this text here, it's this. Now, instead of this looking like the rest, it has been emphasized. So it has been made to look different from the rest of the text. So that's what I can say about text emphasis. So this is how it would look like. Now, so LaTeX also gives us an option for changing the font itself. So it has different font families. So the default font family is the Roman, which is good enough almost. But if you want others, so we have the others are these. So we have sans serif text, then we have the typewriter text. Now, these are the different commands for those different font families. For Roman, even if you don't put this command, LaTeX will know because it's the default. Sorry, it's the default font family for LaTeX. And then this is for sans serif, which this is the command text SF. And of course, remember, for LaTeX to understand that you want to change the font family to this, you need to use this command, and then the text which is in this bracket. Remember what we are talking about, scope. This curly bracket, they create the scope for this command. So any text which is in the middle here will have the font family or change to this. The same thing with typewriter. So this is the command text tt. So anything which is in this bracket will be changed to that. So this would be our output. So this is our output. So we have that, right, for Roman, which is the default font family. Then we have that for sans serif. Then this for typewriter text. So this is just another thing. Typewriter text is a mono space font. So if you, for those who have computers, if you go into your Word document and you want to change your font size to mono space, that would be in LaTeX, it would be it would be typewriter. Then now, so the type of text modifier that most people look for is the alignment. So the default behavior of LaTeX is to stretch the text out so that it fills the entire space between the margin. And this is sometimes called full justification, which is default. Then we have the center justification. So this is the command for center justification. So anything that is in between this, what will happen is, so the text will be centered. Someone is raising his hand. Yes, please. And the person with the question.
Hello.
Yes.
My question, I was waiting you to reach that of centering.
I'm not getting you well.
I made some question. It was requiring. It was like, I'm saying.
I'm getting.
Am I clear now?
Yes, yes.
I made a question. It was requiring us to insert a centered picture in the LaTeX 2 command. Then they were saying that assume the picture is picture EPS. I don't know how we can go about that thing.
Okay, still that now what you will do in that case, you'll have this. You'll have this command, right? This. So we say we have begin center, right? I'm assuming that this is begin center. Then of course we end center, right? Now, the commands putting those images, that image, right? You put now in between here. We shall look at those commands later for including the image. If you're at the beginning of the discussion, we're talking about the graphics package. Now that graphics package, yeah, it's the one that enables us to insert or embed images into our documents. I hope I've answered.
Got it.
I hope I've answered you.
Yes.
All right, let's continue. So now, so this is what happens. This is basically a description of what a center justified text looks like. So let me zoom in a bit. Yeah. Now, so center justified text is aligned down the center of the space. So the spacing between the one is not stretched out, which leads to a ragged margins. Okay, now this is what I'm trying to mean. Now, if you come to the end of, so I'm assuming that this is our margin, right? Now, for center justification, say this is where our text ends. Now, this is now, this has taken the margin from here to here. So that's what we are talking, what we are meaning by a ragged margin. So our margin would look kind of like this, depending on where your paragraph is ending. So that's what we are trying to mean by a ragged margin. But basically, anyone with a question? But basically, what center justification does, it centers our text. Then the next form of justification is the left justification. So the left justified text. So this is the command for the left justified text. This. So it will be begin flash left, then we end with flash right. Now, just a reminder. So if you're writing your code and you begin your flash left and then you don't end, the compiler, there's a question. Where? Here.
Yeah, at the beginning.
This one. Yeah. No. Okay. This. I'm just trying to. How do I say? This one, they don't exist in the command. I'm just trying to tell you that the command for left justified is this. Yes. I'm just trying to put it in bracket just for organization. It's nothing more. Okay. So these are the commands for left justification, right? We begin, then we flash left and end. Sorry, and end, then we flash right, which is this. So this in our compiler, this is how our text would look like. So this is how it would look like. Now, the thing is, so okay, so this is a mistake here. There's a mistake here. Here. Here it's supposed to be left justified text is aligned with the left margin of the page. The spacing between the word is not stretched out, which leads to right margin on the right. Now, so if you look at this now, the right margin is on the right. It's this side. So now, if you look at this, we have our margin here on the left, then the margin on the right. So for text, when you justify your text to the left, this is supposed to be left. It's just a typing error. This is supposed to be left. This is supposed to be left, not center. It's a typing error. Now, we have the margin on the left and the margin on the right. Now, for when we justify our text to the left, now the right margin will be on the right, right? So let me say this is where our text ends. Then we have another text side down here and it ends somewhere here. So we should have, now this margin, of course, say our text goes from here, say up to here. Then it is ending here, right? So our margin will shift from here to here. That's what we are meaning by a right margin. So this would be our margin. This is where our text go, right? So this text goes up to here. For this, the margin is here. Now, then for this, the margin is here. Now for this, where the text is ending, the margin is here. So this is how our margin would look like. So that's what we are meaning, the right margin to the right. So we continue with and we look at right justified text, and this is the command. So this is the command, we flash right. So these brackets are not part of our code. I'm just trying to, it's just for purpose of organization. So this is how our command would look like. Begin. Then we flash, right? So anything here, then, and then we flash, right? So the texts which are here are going to be right justified. So we continue. Yeah, so still this is an error. So when I was writing the codes, I just copied and edited, but I didn't change this. But this is supposed to be left justified. Now this is what we mean by our margin. Yeah, so we are saying that which leads to ragged margin on the left. Now let's look at that. So here, here, so this is our left margin, this is our right margin, right? Now, so we are justifying to the right. Now, if in Word you justify your text to the right, now when you start typing, your cursor will be here. Then when you're typing, your text will be going towards the left. That's in Word. Your text will be going towards the left. Is this, sorry, yeah, towards the left. So it's the same thing here now. When we justify our text, we have this is the margin. So this is the margin for this line, right? Then this is the margin for this line. Now the margin for this shifts to here where the text is ending. So that's what we mean by it's being wrapped to the left. Any questions? Anyone with questions?
No, sir.
Okay, let's continue. So we shall have, now we're going to look at line breaks in alternate text alignment modes. Now, when you're in this alternate alignment mode, you can use 2 backslashes to start a new line, right? So to start a new line, you use 2 backslashes. Just like say you're typing in Word and then you want to start a new line, then you press enter, then you go to the next line. So what these backslashes will tell LaTeX is, no, now let's start a new line or a new paragraph. So then you can add extra spacing between by putting in a measurement inside the square brackets immediately after the 2 backslashes, this. So let me say you've typed this, these are your texts, right? Then if you put 2 backslashes, one, you'll go to a new line. So there will be no spacing here. Now, say if you type, then here you put 2 backslashes, then square bracket, then you put baseline skip. So what this baseline skip will do, it will skip 1 line, right? Then it will start writing immediately after that line. So that's what that baseline skip does. So now you can say, if you want to skip, say 2 lines, right? So you have that, your backslashes, then open, and close square brackets. Now, then here you'll put 2, then baseline skip. So it is telling LaTeX that I want to skip 2 lines. So it will skip 1 and 2. Then on the third, it will start writing your code. It will start writing what you want to write. So this is what I'm talking about. Now, this will just take you to the next line. These 2 backslashes to just take you to the next line, because here we have this is a line of text, right? Then backward slash, 2 backward slashes. So this will just take us to the next line of code. Now here we have this is yet here we have this is another line of code, then backward slash, then let me zoom in so you can see properly. So here we have this is another line of code. Then we have these 2 backward slashes tells LaTeX that go to the next line. It's like you pressed enter on your keyboard. Now, so what this baseline skip does is after going to the next line, it will skip a line. So you'll have an empty line, an empty space before your next. So in this case, it would be this is yet another line of code. Now, then this.
So it will have skipped like 2 lines.
Okay, this are you talking about this? Excuse me.
Yes.
It would have skipped 1 line. Now, what
Yes.
this one does is it takes us to a line. It won't skip. What I get it. Excuse me. Are you getting?
Yeah, I'm getting you. Yeah, I'm getting you.
Yeah, this won't skip. This will just take us to the next line. Now, what this one is the one which skips the line. So this line here, there will be nothing, right? So the line after this line is where we shall have our test. Now this one, what it will does, so the 2 backward slashes will take us to the next line, right? Now, this 2 here will tell us to skip 1, 2, then on the third is where we shall have this written. So this is what I mean. This is what I mean. So now this command would, of course, this would have created this line. Now, then this would skip this line. And now we have our text here. So this is what I mean. So we have 1 blank line because of this. Then if we continue, we shall have 2 blank lines because of this. So that's what basically it means. Let's continue. Now let's look at indentation. So indentation is just where your paragraph begins from the margin, right? So let's say we have our margin here. These are our margins. So what indentation does is it tells LaTeX where you want your first paragraph to begin with. Say this is 1 centimeter. So if your indentation, we shall see how to tell LaTeX to indent to 1 centimeter. So let me say you're telling LaTeX to indent your paragraph to 1 centimeter. So your paragraph, so what LaTeX will do, it will skip exactly 1 centimeter from the margin. Then it will start writing your paragraphs. So that's basically what indentation means. Now, so a new paragraph new paragraph happens when you have a blank line in your code. So let me say you've written, we are saying we are in LaTeX. So we begin document, right? We begin document. In our case, I'm just going to put doc because it's not easy to write. This is supposed to be a calligraphy. Then here we end document. So here we end document. So when now, so if you want to change the indentation, let me just go to a visual example here, right? So this is our document now. So let's look at the preamble. Now, if you want to change the indentation of the whole document, what you do is you use this command, set length. Set length, paragraph per indent, then how much you want your text to be indented. So in our case, we are using 1 centimeter. So our command is set length then per indent, sorry, / first, don't forget the /. So how can I work it? Then para indent, which is basically like paragraph indent, and then so we are setting the length. So we are telling LaTeX. So the length we are setting is the paragraph indentation. Then to what value are we setting it? So in our case, we are setting it to 1 centimeter. To 1 centimeter. So that's how you do it. Now, let's have a look at how. So this. So how much? So this one is our 1 centimeter indentation. If you see here, 1 centimeter. So that is what this command here written does. Set length per indent per then 1 centimeter. So we have set it to 1 centimeter. Okay. Now let's continue. So if you wanted to skip the indentation of a paragraph, so you would use no indent command, which is this. No indent command. Let me zoom in here. This is our no indent command. So this tells LaTeX that, right, as much as I've told you to set the paragraph indentation of the whole text to 1 centimeter, but when you reach to this, you skip it. So which means to this, on this paragraph, there will be no indentation. You get. So it's like to skip the indentation for a single paragraph, you can use the no indent command. You can use the no indent command. So which tells LaTeX to skip, which you can see in our output here. Okay, so what now? Notice that here we are skipping 1 centimeter. We hidden 1 centimeter, then we start. But here, where our paragraph is starting from here, there is no indentation because we have used the no indent command to skip the indentation in that paragraph. And then so you can use several other units in LaTeX, but we won't focus on that now. Okay, you can use inches, you can use points, you can use centimeters, you can use millimeters to set your, depending on what you desire. Somebody is saying that she didn't get anything. She joined late. Don't worry, I'm recording this. I think I'll send a link to WhatsApp group and you'll get it. Now, so you can change the indentation of paragraphs all throughout your file anywhere you want. So now, so here, in this case, so remember here we have set the indentation to 1 centimeter, right? For the whole document, we have set it to 1 centimeter. Now, so these are the other units you can use. You can use inch, you can use centimeters, millimeters, points, EM, then EX. Yeah. So these are the other units which are available for you in LaTeX. This one. Now, to continue. So as we are saying, you can change the paragraph indentation throughout your document. In this case, so we are now changing. Remember, initially we say we want it to be 1 centimeter. So initially we had set it to 1 centimeter from here, and this is here where you see the green marks. So where you see the green marks, we had set to 1 centimeter. But now, as I said, that you can, it depends on your liking. So you can change your indentation throughout the paragraph. Now, in this case here, we have changed it. We are changing it now from 1 centimeter to 15 points. So where you see the blue marking here. So we have changed it from 1 centimeter, and 15 point is much smaller than 1 centimeter. That's why you say, if you look at it well, let me draw a line. So this is our 1 centimeter, right? This red one. So this is 1 centimeter, then this is 15 centimeter. Now, so we have changed here in this part. If I zoom in here, we have changed it to 15 points, but previously it was, for the whole document, is set at 1 centimeter. Here, we have set at 1 centimeter, but now here, down here, we've changed to 15 centimeters. So I'm just trying to show you that depending on what you want, the type of document you're typing, you can change the paragraph indentation to your liking. You can change it to 20 points from any, say, you can even say maybe if you want each paragraph to have its own indentation. So you could come here and say, let's say this paragraph. So we put here, set length, then paragraph indentation, indent, right? Then we set the length to say maybe 2 centimeters. So we set it to 2 centimeters. So if we set it to 2 centimeters, then this paragraph, because we are changing the one of notice. So this paragraph would say start from around here. You get. So basically, that's about indentation. Any questions?
No questions, sir.
Okay, let's continue. Now, we are going to look at our next thing is going to be math mode. So in the next few slides, we shall look at the basic use of mathematical symbols in LaTeX. Now, that's in math mode. Now, up to this point, we've been dealing with text. And if that's all we want to do, then it would be useless to even study LaTeX, because you can deal with text in Microsoft Word. There are very many other Office suite softwares that can help you to deal with Word. Now, the real beauty and power of LaTeX is the ability to handle mathematical notations. So the first concept we shall talk about is math mode. Now, so math mode, this is an environment with rules to typeset symbols, right? So there are two types of math modes. One, we have the display style math mode, and then the inline or text style math mode. Now, we shall look at the differences and how to use these different style of math mode. So let's start with the display style math mode. So display style math mode is intended to be used when mathematical equations or expressions are meant to stand apart from the rest of the text. So this is what I mean. Let me say, you're saying, let me say your text, okay, let me say the formula, you're saying the formula. So this is the text is saying the formula of force is given as F is equal to M A. Then you continue where say M is mass, then A is acceleration. So here we have used the display style of math. It makes your formula to stand alone, right? So what other words, where it's putting it on display. Putting it on display meaning that when you look at your writing, you will immediately see that your formula is separate from the text, right? So that's what the display style mode does. So let's look at how to use it. So it's often used for longer mathematical equations or expressions. So the expressions always break the paragraph and are always centered, right? Now, there are two ways of creating a display style equation. Number one, you can use this. You can use this square bracket. So for backward slash open square bracket, then then backward slash close square bracket. So whatever is in the middle here is your expression or equation. So in this case, we have this fx is equal to x plus 2 squared minus 9. We shall look at how to write this in LaTeX, and it will appear the way you want it to appear. Then the second one is using a display math environment such as begin align, and end align. Now, this is our display math environment, and we shall see how to use it. So the align environment is specifically designed so that your equal signs will be lined up if you have a set of related equations. So let me say you have f of x, this expression, the way it is. Then we want to expand it, but we want it to look in such a way that our equal signs are on the same line. So that's when we use this disalign command. Now, just this star here, usually, okay, the command is actually this: begin, align without the star. So what this star does is, if you have your align without the star, then your equations are going to be numbered. So if we didn't have the star, so you would see at the end here would be equation 1. Then if you have another equation down here, then here it will be 2. So what this star does is to remove the numberings of the equations. Any question? If there are no questions, let's continue. Now let's continue. Now let's look at an example. So of course, remember the align the align environment starts with begin align as usual. Hold on.
I have some questions, sir.
Yes.
Yeah, I can see that like on the math environment, the begin align start that thing of star stands for what?
Oh, I was just explaining. Now this star here, okay, just tells LaTeX. Usually, the command is just begin align without the star, right? Now,
yeah.
So what this star tells now, when you write your command with just align, then your equations are going to be numbered. You get?
Okay.
Yeah, your expressions are going to be numbered. Now, when you put this star here, right? When you put this star, then your expressions won't be numbered. We shall look at. I have a code sample. You're going to see how these things work. Now, of course, you begin with begin align. Now, then after you put your expression. Now, notice that at the end of our expression here, we have this double slash. And remember when we were talking about previously that this one help us to go to the next line, right? Now,
yes.
So I remember here I was saying, if you maybe say you have many expressions, you can use this. So what the backward slashes tells us is we are going to the next line, and now that next line is we have another equation, another expression here, right? Now, if you notice, we have this and percent sign, this and sign here. Now, what this and sign does is it helps us to align these equal signs in the same line, makes them to be in the same line. Are we together? Yeah. So what this and sign does, it puts the equal signs, it aligns them in the same in one row. Sorry, in one column. Yeah. So we continue. Now, of course, after putting in your formula or your expression, we end our align command, because if you don't end it, when you try to run your program, that the LaTeX compiler will complain in form of an error. Now let's continue. Still on the display style. So remember, for us to be able to typeset math expression and equation, we need to use the AMS math package. So before we even, before we do this, in your preamble, you need to include this package. You need to include this package. If you don't include that package, then when you run your code, still LaTeX is going to complain in form of an error, right? So for you to be able to use math mode, you must have this, the math package, the AMS math package included in your preamble. This is what I mean, this package. Sorry. So this is what I mean, the AMS math package. So for you to be able to use math mode, before you use math mode, you need to have this package, this one, included in your preamble. Then you can now successfully use math mode and put your expressions. Okay, now let's look. Yes. I looked at that before you came. Someone is asking me what a preamble is. I think we already looked at. It's what when you are looking at the structure of the LaTeX document, right? We add the preamble and the document environment. This one. Now, this preamble, it contains, this is just a portion of your code that contains packages. Yes, that will tell LaTeX what, or it will help LaTeX in your, so let me say that certain things you want to do with LaTeX. So if you want to write mathematical expressions, you include this package that in the preamble, you can't put it here. So here and here, this one is the document environment. So which contains the actual content, the content that appears here. So what is here in the environment, so the document environment is what you're seeing here. But this preamble, these are just codes that work in the background that help in the editing of your code. Yeah, so that's basically the preamble. But if you missed the beginning, I will still send a link of the recording lecture. So let's dive into this code now. Remember, the first thing for you to use math mode, you need to have the math package in your in your code now. So we are looking at the display style. So we are saying that in the display style, yeah, our code, our expressions will be on display. They will be centered. It will to start on a new line and will be centered. So now, and this is the command for our display style math mode, or you can use this. Or you can use this. But personally, I prefer this. You can also try this. Now, which you see, I've tried it down here, and you will see the effect. Now, let's look at the output of our code. Now, for now, don't focus on how this form out. Don't focus on this right now. For now, let's focus only on the output. We shall look at how to write this so that we can come up with this. But for now, let's just focus on the output. Now, if you notice now here, our code, just as we had said that with the display mode, it breaks a new line, yeah, and the code is centered. Then this and sign, this one, helps us to align these equal signs the way you're seeing the line here. Yeah, so these are our codes. So this one is what is displayed here, and I think I basically explained why these equal signs are aligned. It's basically because of this ampersand sign. Now, let's look at the other way of writing our display style mode, which is using the square bracket, the backward slash square bracket combination. So when you do that, anything which is inside here is going to be here. But remember, for you to do the key point here in math mode is for you to use math mode, you must have this packet included. If you don't have it included, you're going to run into problems. LaTeX will complain, you'll have error messages. Now, so aligning mathematical equations. So let me say you're writing, you want to have this form of an equation, right? So the display style math mode will also help you do that. And the way you do that is by use of this and this. So this is what I mean. Now this, this one, right? These and signs here, it helps us to create the space. It helps us to create that space. Then, of course, remember we already looked at how to write this. If you want our expression with equal signs on the same line, we use this. So, and of course, remember, still we are still in display style math mode. We're still in display style math mode, and that's why we have this. We are beginning our align and we are ending. Then now the rest of these codes are in the middle here, right? So we continue. Then we have then this will create this space. So remember we were talking. So just in case maybe you need to have numbered equations. So let me say you're typing your notes, and then you have several equations that you want to refer to later in your document. So LaTeX will automatically number your equations if you use this command. Now notice that in our command here we no longer have the star. We no longer have the star, but in the previous we had begin. Yes, someone raised up his hand. What's your question?
Yeah, I'm just my question, like the way that thing separates the and, that and sign.
In the previous slide.
Yeah.
Hold on, let me go back.
That and.
Here.
Yeah. So like that and sign, can it be used as the same way, like if someone uses, let's say, slash, two,
slash, first goes for slash, Q.
Double Q. Then U, A, D. I don't know whether that one also can be used at that point.
This I'm not so sure. But
okay.
To me, this one is much easier, right? This because you just write it horizontally. So if you do this, if you had only done this and we didn't have this line of code, then we would only have this. Yeah. I don't know, maybe if is it hard for you or you're just trying to inquire?
I wanted to know whether I can go to this one, because the other one, like they told us, like from the book, that you can use slash choo UAD say that it brings like it makes them go aside like the way those ones are.
No,
So I think I need to practice that one. Then I see.
it's okay.
All right.
Yeah. So can we continue now? All right. We are looking at numbered equations. Now, so previously, when we were using the begin align command, we had a star here. And what I'd say that star tells LaTeX not to number your equations. So let me say you're writing maybe some text, and then you have several equations that you want to refer to later in your document. So let me say you're substituting somewhere, say may substitute equation 1. Let me say you're solving a spontaneous equation. And then you have equation 1 is A plus B. Say is equal to 1. Then you say you label it equation. You want to label it equation 1. Then you say maybe then A plus B is say -2. And say this is equation 2. Now, if you use the align star, you're not going to have your equations labeled. But if you use only this command without the star, then LaTeX will automatically number your equation automatically, meaning the first expression you write will have the numbering of 1. Then the second will have the numbering of 2. That's what LaTeX will do. So just in case, let me say you want to number, say you have 3 equations. Say equation 1, A plus B is equal to 1. Then say A plus say C is equal to 2. Then let me say C plus B is equal to 3. Now, so let me say you don't want to number this equation. You want to start numbering from the second equation. So what you do, before you write this, you use this command. Before the end of this line, you write this command. We shall see. We have an example. So this is what I mean. From my code here now. We have, of course, remember, all this will only function if we have the AMS math package in our document now. So let's say, of course, this is our begin align command that that helps us, tells LaTeX that we want to have numbered equation. So now, and we looked at how to do this in the previous slide. So here we want to tell LaTeX that, of course, number these equations, which we see here in the output. Let me zoom in there. So we want to tell LaTeX that now number these equations. So that's when we shall use this command. So when we use this command, we have that. So the output here, we have the numbering of 1, 2. The reason as to why we don't have the first equation numbered is because we are using this command, no number. So we're telling LaTeX that, of course, number these other equations, but for this first one, assign to it no number. Let's say we had put this no number command here. So we would have the output with here the output. Now, what LaTeX would do, it would number this equation as equation 1, then it would skip the numbering of this. Then we have equation 2 here. Or if we had the no number command for this, we would have equation 1 here, equation 2 here, then no numbering here. Okay. So this is what I mean. So this no number command here, we shall have no numbering here, but the numbering starts from the equation immediately after that one. So that is all with all to do with the display style math mode. Now let's have a look at the inline or text style math mode. Now the inline or text style math mode keeps the mathematical expressions as part of the text or the paragraph. So it exists in the line. So this is what I mean. So let me say, would say the formula of force is, so instead of coming to the next line, it will continue from here. So F is equal to M A. So that's what the inline or text style math mode does. So it keeps our formula in the same line as the text. So for inline math mode, we also have two ways of we also have two methods that we can use. So the first one is using the dollar sign, this. Then we put the expression in the middle. So for example, this and this, then these are expressions. So this is our inline. That's the first method. Then the second method is using the open bracket, close bracket command. So backslash, open bracket, forward slash, close bracket command. Now, so the dollar sign method is slightly old, but people still use it. But if you're just for new learners, I would recommend we use this. But both of them work in the same way. So ultimately, there's no difference between the two. Now, so whenever you're talking about, say, math variables, right? The inline display style, so the inline text math mode style can come in handy. So this is what I mean. So here we are using the dollar sign. It's the same. We have this. Then here we're using the open and close format, which is the same. So it's basically the same. Here you're seeing that, and then for the backslash open bracket, it's the same thing. So you can use the one which you find is much easier for you. Now, so let me say you're writing your document and then you want to talk about a variable, right? So let me say you're saying F is equal to M A, where A is acceleration and M is mass. Now, remember, now these ones are variables, right? So now LaTeX has a way of differentiating the variable A and letter and the letter A. They look different. So and that can easily be done using the inline or text style, so which we have here. So it's useful when talking about math variables. So if you look at the variable X here, the variable X, this is the command, and then we have the normal letter X. The normal letter X is different from the variable X. So that could be one of the uses of the inline or text style mode. Now let's look at some differences. Of course, we already know a few differences between the math mode and the display, and the inline or text style mode. Now, of course, you know that the math mode will send your equation to a new line and is sent that. And we know that the Style mode will keep it in the same line as your text. But now, so aside from placement of text, inline and display styles are presented differently. Here's an example now. So now this is we shall look at how to write this, but this is basically sum of n is equal to 1 to infinity, then 1 out of n squared is equal to y squared out of 6. This is something of that kind, but we shall look at how to write that. Now, I just want, I'm going to write the next sample of codes that I'm going to show. Will show how to write this, how this is written in display style and in inline style, and you see the difference. So this one is in display style, and this is the difference. This is the output. Then this is in inline or text style. I hope you guys can see the differences in the output. So these are the outputs. So if you notice now, one, the display style, the output is much bigger than the inline style, and it's arranged in a more vertical order than this one. This is more horizontal. So that's one difference in the presentation of the display style. So this one, these codes are the same, but their outputs are different. So display mode is larger and stacked more vertically. That's what I mean. It's larger and it's stacked more vertically than the inline or text style. So this is what I mean. That's the display mode, that's the output. And the inline mode is smaller and stacked more horizontally. So that's the inline style mode. So continue looking at the differences. So the display style creates a space between lines that can sometimes look awkward. Now, this is a disadvantage with a display style. So if you look at this, there is a sort of disorganization if you see, because I'm very sure here you're trying to write this code to follow this line, then and this. But with the display style mode, if you use the display style mode to write your expression, there's going to be that awkward space created by it, this space here, which is really not required in this kind of writing. If you're writing such a thing, because they're saying the visual problem is a problem. If you look at it, it's a problem of computing the sum of squares, blah, 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 and all that stuff. But now when you use the display math mode style, it will create this weird awkward space that you really don't need now. So it's actually a disadvantage of the display math mode style. Then the inline style doesn't create spaces between the line. So this is the display style, and we see that there is no awkward spacing. It's just organized in the way you want. So basically, basing on the kind of document you're writing, you choose the one which best suits you. If you wanted to, if you're writing, say, many expressions, it's recommended you use the display style math mode. If you want to write, say, this kind of text, then you use the inline or text style mode. Now, let's look at basic mathematical notations. So so the notations must always be inside the math mode. Now, just as I was emphasizing that you cannot have math mode we are working without the AMS math package. These notations that we are going to look at, all these notations are supposed to be inside math mode, either display math mode or inline math mode. So this is a display math mode. So inside the display math mode, these notations, they're supposed to be here. Same thing with the inline math mode. So the notations that we are going to look at right now, yeah, all of them I may not be putting them inside, indicating that they're inside math mode while explaining them, but you should always remember that these notations that we're going to be looking at should always be inside math mode. All right. So the basic, one of the basic notations we first look at are the 4 basic functions, which is the arithmetic functions. So we have these are the ones. So we have the addition. Now, addition in the normal math text, this is how we write addition, and it doesn't change also in LaTeX. So LaTeX code, it will also look like 1 plus 1. So let's say in addition we're adding A plus B. So here it will also be A plus B. It doesn't change. It will remain the same. So this is still, remember what I was saying. So all these should be inside math mode. So how it would be say we are writing this is display. So this is inline math style math mode. So here it will be 1 plus 1. It remains the same. Same thing with subtraction. Subtraction would also be the same thing here. Now, multiplication, you don't want to use this sign. So if it's a dot multiplication, you use this command, backward slash C dot. So this one is 6 times 4, which is 6.4. So this is how you present multiplication. Or if you want to use this one times, so you'll use backward slash times command to write your code. So in our case, in this case would be say I'm using the $sign, it will be $6 / times. So this is inline times 4. So this is how it would look like. This is our command in the LaTeX. Then this is how it would look like. Yeah. Then division. Division, we won't use this. We shall use the backward slash division. Now, there's a caution when you're using the division sign. So you should be cautious when you're using it, because let me say you have multiple expressions. So let me say you have 2 divided by 6. Then let me say we have 2 plus 1 inside here. So it would be best to write this as 2/6, say, into 2 plus 1, rather than writing it like this. So so this is how they will look like. This is an extract from So this is how our commands would look like. Right, so this is addition, which is here. This is the output. Now these backward slashes, if you remember, they will help us to create space. So that's why I have this and then a space here to create this space here. It's something I think we already looked at that previously. Then we have this for that. Then we have this for the dot product of 6 and 4, which is this. Then we have this for the cross product, which is times, which is this and this. Then we have this for the division, which is basically what I was explaining previously. So now the division notation is what I was trying to talk about. So instead of presenting this, presenting it in this form, it's much better to present it in this form and this form because it's for easy readability. It can easily be read by the user. I don't know if you guys are getting me well. So let's continue. I don't know if it's okay if we stop at 1. If it's okay with you people. Someone to say something.
Yeah, I support that we stop at 1.
Yeah, let's stop at 1. So I think so we have around 43 minutes to go. Okay. So let's continue. Now so instead now if you notice here, now we're using fractions, right? We're using fractions. So let's go ahead and see how we can use fractions. Of course, in our code here, we see how to use fractions. Now let's dive deep into fractions. So fraction. So to create a fraction, we use the backward slash frac command. We use this backward slash frac command. So this is to create a fraction. So then, and with the content of the first bracket the content of the first bracket goes to the numerator. So let me say we're writing a fraction a half, right? So our fraction a half, this one would go in this bracket, and then this 2 would go in this bracket. So basically that's what it means. So the frac notation will take LaTeX to pick the size of the content based on the context. So so now this is our fraction in display style math mode. It's stacked vertically and it's much bigger. If you remember when we're looking at differences between the display style and the inline style, and in our inline style, this is how it will look like. It's hard to notice the difference, but it's more horizontal, so horizontal, and it's smaller. All right. Now, so let's look at the command. So so just in case if you wanted to tell LaTeX that the fraction that I want to write should be in a display math mode style, then you use the command dfrac. So it will tell LaTeX that this fraction, say the half that I'm writing, should be displayed in the display math mode style. And then if you want it to be in the inline or text display text style, then you use the tfrac command to display it in that form. Yeah, so that is it with fraction. If anyone has a question, you can answer. If you don't, then we shall continue. Any questions? I assume there are no questions. So let's continue.
No.
Okay, let's continue. Now we shall look at, so let me say you want to write x squared in LaTeX. So how do you write the superscript? This squared here is what is called a superscript. Or say we want to write x naught. How do you write it in LaTeX? So this note here is the subscript. So this is another aspect, use of mathematical notation. And so this is when you have the small text above, that's the superscript. When you have the small text below, that's a subscript. So we can create a subscript by using the caret symbol, which is this, and we create a superscript using the underscore symbol, which is this. We shall see how to use it. So here I have a table, basically summarizing. Now, this is a superscript. The symbol is this. Then the subscript, the symbol is that. Now, the symbol name is the caret, this one. Then this is the underscore. Then an example code. This is how you would write the code in LaTeX. But always remember, this code must be in math mode. So this how this would be in inline style display. It would be x to the power 2. So they must always be in the math mode. Now, and of course, the math mode will only work if there is a package, the AMS package. So this would be the output. Then this is how the code will look like, and this is the output. So use of brackets for grouping. So let me say if you have both subscript and superscripts, they will be placed relative to the main character. So let me say you want to write something of this, a naught squared. So how do you write this? So this is how we use the brackets for the grouping. This is what I mean. Okay, now let me say this is what we want to write. So the best way of writing when you're grouping. So let me say you want to write e times the function of x, and x is equal to, say, x squared, something of this sort. So this is how you would use the bracket. So the characters that you want to be up, you put them in this bracket. Because if you don't put in bracket, LaTeX will only look at this as the one you want to make a superscript. Then this one here, to look at it as a normal variable. The same thing with the subscript. So if you have, say, this and you want it to have k x, so to have all of it, you put them in this bracket. If you only put one, if you only put like this, right, it would display something of this sort, subscript k, then x.
I have some question here.
Okay, it's okay, you ask.
Okay, like this thing, I have seen the code of exponent power kx. Now what if it is exponent kx squared and the squared is on x? How can we do that?
We shall look at that. We are going to come to that, don't worry. So if,
okay,
you're talking of this, right? if you have k, then squared, like this, right?
E to power k x squared.
Yeah, is that what you're talking about?
The squared is on x.
The squared is on x.
Yes,
The squared is on x.
on x. Yes.
Something of this. E to power k.
X squared.
Okay. X.
Like this. Or is
No,
the x also up?
no. All of them are up.
All
K
of them
then
are
with
up.
x there, and then x is squared.
So this out. Okay. So you want k x then squared, right? So
Yes,
this,
yes,
this
yes.
how it would look like. So we have something like e power. Then we are grouping them in a bracket, right?
Yes.
Okay. Now we still have our bracket, right?
Mm.
So we have x, but we want the x squared. Now let me use a different color. This color. So now to have this squared, we shall have this. Then we put our 2 here.
Okay.
Yeah, something.
Yes, sir.
Yeah.
Mm.
Okay, let's continue.
Thanks.
You're welcome. So so simultaneous as superscripts and subscripts. So that's what I was talking about. So we have this. So this is how you write it, and this is how you interpret a sub 1 squared. They're basically the same thing, just a difference in interpretation. Then this would be a squared sub 1. So in our case would be a1 squared. So this one is it's a squared sub 1. So that's how you present them. So we have combined superscripts and subscripts. I think this rotates towards what you are asking, only that here we are having a 1. So now, so in this case, so our case, this is what you wanted. Okay, x squared. Now, so you also have the ability of stacking these superscripts and subscripts, just as we were doing in the previous slide about what you ask. Then this is how you would do them. So just in case maybe you had a, so p1, then to power a1. There's a mistake here. There's a mistake. There's a 1 which is supposed to be here. Sorry, there's a mistake. And there's a 1 which is supposed to be here. I'm going to correct that. Yeah. This is supposed to be p underscore 1, correct? Then a underscore 1. There's a mistake here. This is how it's supposed to be, but I'm very sure you're understanding. So let's continue. So so this is our summary of what we're talking about, the code. Now, this is just a normal superscript. This is how it would appear like. This is how a normal superscript would appear like. Then a normal subscript, this is how you write it. This is how it would. And still remember, we are all of these. I just cropped a part of it, but all these are inside a math mode. And if you can see from here, this is inline math display. This is inline or text math mode. All of them, if you see this and this, this, and this. We could also use a dollar sign, this and this. So it's always key to remember that when you're putting these these notations, you have to be in math mode. So then grouping the brackets, this, we have this because of that. Now, the next one here. So here, without bracket, we have not, yeah. So what LaTeX will interpret, let me zoom, I think they're very small here. So here, what LaTeX, the way LaTeX is going to understand it is, I want to only, it's only the K that I want up, right? Not both of them. If you want both of them, then you have to group them in this bracket, right? Now, let's look at this. Now, so this, the way LaTeX will interpret it is A1, this one, the way LaTeX is going to interpret it is, we have A, sorry. So we have here. Here, sorry, this one. The way LaTeX will interpret it is this. So simultaneous superscript one. They are basically the same thing. It's just different ways of writing them. Now, then for superscripts, we also have that. Now, the mistake which was in our slide is corrected here. This is the correct thing. In our slide previously, we missed out something. But this is the correct code. And the display is right about here. Here. This is our display. This one is the display and the code is in the previous thing. I think that's with superscripts and subscripts. Now let's look at parentheses. So you can use the standard parentheses and square brackets on the keyboard. They are sometimes effective, but it sometimes becomes hard to understand. Let me say you want to write 6. So 1 or 6 in brackets. Then you have another bracket. Say x plus 2, say over 2. If you want to write this now. This is okay. But now the challenge with this is these brackets are of the same size, which can be hard to interpret. It cannot be hard, it can be hard to read. Now, of course, LaTeX comes as a way of dealing with that. So this is what I was talking about. These parentheses are very hard to read. If you look at it, this is this. This is this, and then this is this. Then we have this. Is this. So it's hard to read, and this expression is okay, but then the challenge is it's very hard to read, because now if you look at this A and B, they're outside of this bracket, and yet they're supposed to be inside this bracket. So how do we go around that? So you can use this, you can manually choose the size of the bracket you want to use. So LaTeX can choose for you the size of bracket if you use this command. If you use this command, backward slash left, open bracket, then close, right, then when you close the bracket. So if you use this command, let me zoom in a bit so you can see. This command, if you use this command, so LaTeX will automatically choose the size of the bracket that you so in this case, LaTeX would make this bracket much bigger than the ones which are inside. So it is much easier to read and interpret. Yeah. All right. So this is what I mean. So LaTeX will choose it will choose for again. There's a mistake somewhere. This one, this bracket here is not supposed to be there. Just a typing mistake. This bracket is not supposed to be here. Forgot to remove it now. So when you use this command, the left open and close right. So LaTeX will automatically choose the size of the bracket for you, which I believe this is much easier to read and to understand. So you can customize the size of the parentheses. This is what I mean. So if, let me say, if you wanted this to be bigger, right? This bracket to be bigger. So what we could have done, we would have come, say inside, say here. Here, we could have come and say, open, big. Depending on the size, the big size you want. If you want it to be this size, you start with, so let me say we want it to be this big. So we start with capital B, then open this, then we close big. So these codes, we will put this inside here, such that we would have this bracket being, say, this size. This size. So you can customize the size of your parentheses or brackets. So for the left and right, this must come in pairs. This one, this, when you're using this, when you're using this left, they have to come in pairs with this. So what it means that this is our opening bracket, this is our closing bracket. But just in case, for some reason, let me say, you want to write an expression, say a function, this is our function, right? But we want to only have, say, an open bracket, and then we don't want to close. Then this, what you will do, you will open this bracket. You'll open the bracket left, then write your function. So here, where you're closing, you close, but, sorry, this is supposed to be right. You close, but instead of a closing bracket, you put a full stop. So this will tell LaTeX that I only want to have an open bracket. I don't want to close it. So that's what that's how LaTeX will interpret it. So the left and right must come in pairs. Otherwise, you will get errors in your code. Then open brackets, we use the commands this. So this one will open, then this and it won't close, then this, not this, it will, we shall have a closing bracket, but no opening bracket. So that's what that line of code basically means. So we have an example here. So if you look at this, we have this open, sorry. We have this which is open and it's here, but here we are not closing. So there are two open brackets, this and that, but we are not closing any of them. So just in case if we had included, say, a bracket here, so we would have a closing bracket here, but none here. So that's what this code means. There, and if you look at it, that so this one, which is the first bracket, it's supposed to be closing here, but we don't have. It's supposed to be closing here, but we have told LaTeX that we don't want to close it, so it to remain blank. And then this one, which is supposed to be closing here, we don't have it, so we have told LaTeX we don't want to close it. Same thing with down here. So down here, we are not opening anything. We're telling LaTeX don't open, but you close it here. You see. Then here we are also telling LaTeX open, don't open anything, but we are closing it here. So that's what we have. Then we have, so let me say you're already in text mode, in math mode, but then you want to write some equation. Okay, let me say you have that, okay. So we're saying using text command while in math mode. So if you want to write text in the middle of math mode, you cannot simply type the text. LaTeX will interpret the whole thing as a product of variables. Instead you need to use the / text command. So this is what I mean. So let me say we're saying n is equal to AB, where A and B are natural numbers. Now, remember, by the fact that we have $sign here and $sign here, we're already in math mode, not so? Now, if we leave it like this, so this is how the whole thing will be displayed. So this is what would be displayed, because LaTeX will interpret A, B, where we'll interpret all of this as a product of variables. It will look at W, each of these letters as variables, and it will multiply them. Instead of printing, outputting this is actually what we want to be the output. We want this to be the variables. These are the variables. These are the variables. So where I was saying, but these are normal text. So we want it to be displayed in this form. I see. So to do so, we need to use the /text then command. So here we would have backward, then text, then our where would go inside here. The same thing with and would also go inside here. The same thing with R, the rest of this text. But if you write in math mode like that without using the text command, this is going to be your output, because LaTeX will look at them as variables which are being multiplied. So that will be your output. So yes, question.
What if you put a $sign only on those variables? Like for A, you put separate, for B also separate.
So if you put here, 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 here. It's okay, but are you saying that it's already tiresome? Are you saying it's if you do that, if you put the dollar sign, so which means you also have to put here on this, you also have to put here. Are you seeing? So we're having 1, 2, 1, 1, 2, 3, 4, and then we could only have 1, and then we use this command to help us bring out what we want to see, right?
Yeah.
So if you want to do that, it's also okay. It will bring the same thing. Yeah. So now. So this is what I mean. Now, if you write it like this, without the text command, this is our output. That is our output, right? Now, the text command. So we have included the text command, but we are noticing that there is still some problem somewhere. Not so. It's only this one which is separated the way we want, which means there's a condition which comes with using the text command. Now, for you to use the text command very well, you need to put an exclusive space. This is what I mean. So before you start writing your words, you need to put, there is this space that you need to put. Let me zoom in so you can see this space here, you have to put. Otherwise, if you don't put, what will happen, this text here to just start from here immediately. I say to start from here immediately, and that's why we're having this funny output. That's why we're having this. Well, that's why we're having this. Because when we did this, this is text. We just started where from here. So we were supposed to leave space here, then start where with this space here. So that's why you're seeing where A and B is still looking as a product of variables. But now Latex now knows that these are what? These are words. These are not variables. But you've not put the space, this spacing here between the variable here, because we have A, B here, then our text. So we didn't leave any space here. That's why LaTeX is interpreting it this way. So so this is the proper way of writing it. This is the proper way of writing it with the space here, because if we didn't leave this space, again, if we didn't leave this space here, so we would have had something of this kind, where then this A would just be put here if we didn't leave. So we have to leave the space on both before and after writing our word. So yeah, so then text, then again we leave this space here and here, then again we leave this space here and here, so that we have this proper display, because this is what we want to see. And notice that this A is different from this A. Why? Because this A is a variable and this is just a normal letter A. So that's the difference. Now there's this is optional. So let me say we only want to have our text alone, then the variables alone. You get. So we are saying, because here this is our inline or text style math mode. This is inline or text math mode. Now we want n, this is our expression, n is equal to ab. Now we want to have text, so we are saying text, right? Then we are including where. Now if we had only put a inside here without this, we would have a normal a, not a variable. So we would have this a that we are saying. So we are saying where a. Now remember, this is inline style math mode, right? Even this is inline style math mode. This is inline style mode. So what this is trying to do is trying to, remember now here we have how many text command? 1, 2, 3 commands, right? But here we only have 1. It's basically similar from what the other person was asking, putting these dollar signs here. Sorry, putting these dollar signs here. Here, 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 and here. But here we are only putting twice because we already have for this, for the whole of this and this. So the display is the same as this one. The only difference here is your code is much easier to understand. Yeah. So then another important set of symbols are the Greek letters. So we have those Greek letters we use, the pies, this, that, name them, all those that you know. So there are commands for them in LaTeX. So they are available in math mode, and to use them, they're available in math mode and can usually be created by the so you type /, then the name of the letter we are going to see. So the name of the letter, then you have the output. So here is a table showing all showing the full Greek alphabet. So you'll notice that you'll notice that there are some Greek letters that don't have a special command. This is because the Greek letters are the same as the alphabet that we're using. So these ones that I've marked, if you look at A, capital A, there is no special command for capital A. If you look at capital B, the same. You look at H, look at N, they are the same. These ones that I've marked, there is no special command for them, so they just stay the way they are. So you'll also see that, but for these ones, if you look at it now, if you want alpha, you would put /, then alpha in 1. Then it will display for you your alpha. So the same with beta, gamma, delta, epsilon, zeta, all these. So we have that. Then you also notice that there are a few lowercase letters with multiple forms. So these ones, if you look at them, for theta, there are 2. There's theta, then there's var theta. Then we have epsilon, then var epsilon. Then rho is the same thing with phi. Now, this variance is created by adding VAR in front of the Greek letters. This is what I mean. So here, if you look at this, there's if you look at this, there's VAR here, and there's VAR. So there are 2 different ways of writing them. We have 5 minutes, but I think let's just wrap up very fast. Then we have the AMS Blackboard font. So let me say you want to write complex number. The symbol for complex number is this. Then we have natural number, something of this kind. Then and very many others. So LaTeX also gives us the option of using them. Using this, if you remember this, AMS, the American Math Society, they created this font, and for you to use it, you need to include the AMSIMB package. That's the American Society symbol package. Which I think I already showed you how to include those in the package. Yeah, so now there are other pieces of mathematical. So this is the these are the Blackboard fonts. So let me say if you want complex numbers, so then there is that and all and then the rest. So let's look at some examples. So here for natural numbers, we have that. Then for integers, we have this. So remember, for you to use it, you need to have this command, math BB, then the letter. So you can put any from A to Z, then you have that, which is that. Then this for natural numbers, then integers, rational numbers, real numbers, and complex numbers. I think for now, for today, we shall stop here. In case there is any question, you're free to ask. Is there any question?
Okay, Hilary.
Yes.
Man, thank you very much for what you have just done, because man, you have just changed me.
Thank you.
I have been, yeah, we've been struggling, trying to read, but things are not coming. Thank you. How I wish then, like every Saturday you organize this Zoom, and then yeah, we try to do like this, the assignments they gave. Now like my group, they just did things and I don't know stuff. But I think if you can continue like this, man, thank you very much.
Yeah, that is what I want to do, because in this short time we can't cover everything, because
yeah,
we still in LaTeX we have to look at tables and arrays. Then we have to dive into those integral signs, differentiation. There are very many things that we can't cover them like in a short period of time. So for those who are interested, because it's supposed to be a group discussion for my group, but then I decided that maybe there are other people who also want to learn. Then
yeah,
that's why I created the Zoom. So just on Saturday again, we shall have the same session. Of course, we shall continue from where we stopped. We go forward. Then, of course, at some point we shall look at the assignments which were given. And after, when I feel we are done with LaTeX, then we can also look at Fortran. And
yeah, for sure. Thank you very much.
You're welcome.
Yeah.
Yeah. If there's no more question, then I'm going to stop here for now.
Okay. Happy Resurrection Sunday.
All right. Happy Easter.
Yeah.